Hey guys, welcome back to another video, and today we're going to be starting our physics course in physics videos. And today we're going to be talking about kinematics. Kinematics is the study of motion in which we don't actually consider what causes that motion. So we'll use acceleration, but we won't consider force. We won't consider why that motion happens. We'll just analyze that motion. So we'll talk about the kinematic. We'll talk about the definitions that you know for kinematics, the important equations that you know for kinematics, you need to know for kinematics, and we'll do some problems. Okay? So the first thing you gotta know for kinematics is how are things defined? So the first really important thing you need to know is that things are defined based on two things. You need to know that you can be defined based on either your position in space or the time that something occurs. So those are the two things that are really important to know how certain things are defined. For position, we generally use the symbols. We use the symbol of x or r. R is a vector, meaning it has direction, and r is composed of its x, y, and z components. For example, if you have a coordinate grid, then r is the vector that points to where your position is at any one moment in time. Okay? So that you would say is r. Okay? Now, we can use position to get something that's equally as useful, and that is displacement. Displacement is the change in position. So, for example, if I move 1 meter to the right, you can say that my displacement is 1 meter to the right. Notice that both position and displacement are vectors. They both require a magnitude and a direction. I need to specify a direction for my displacement. Generally, the accepted coordinate system in physics is that right is positive in the x direction, left is negative in the x direction, up is positive in the y direction, down is negative in the y direction. That is the accepted conventions for coordinates in physics. So displacement, we use the terminology delta x. And then, obviously, since it's a vector, there's also delta r. For example, say this is r at one point in time, this is r at another point in time, then your displacement would be r final minus r initial, or delta r. Okay, and obviously delta r is composed of delta x, delta y, and delta z. Okay? Now we will use displacement to define something else, and that is velocity. Okay? Over a small interval, you can define velocity as the displacement over the change in time. So, for example, if I move here, say 2 meters in the time period of 2 seconds, then you could say my velocity is 2 meters over 2 seconds, or 1 meter per second. Note that velocity, like displacement, is a vector. You need to know the magnitude and the direction. Note the velocity is very different from speed. For example, let's say I run around and I come back to the same spot. My displacement is 0. So even though my speed was never 0 when I was running, my velocity is 0 because my average velocity is 0 because my final position is the same as my initial position. So therefore, velocity in that case would be 0. Now, since this is only for a short time interval, can v equal delta x over delta t? In order to find what a v actually is, we have to take the limit as delta t goes to 0. Or in other words, v is equal to dx over dt. Okay? And just so we aren't confused, I will erase this original definition. Okay? We will have v equal to dx by dt, or it's often called as x dot. Okay? X dot just means the first time derivative. Okay? v equals dx by dt equals x dot. What does this mean? This also means that v average is equal to delta x over delta t over long intervals. Over larger intervals, it is more useful to use over longer intervals. In order to find the average velocity, you must use delta x over delta t. Okay, that is average velocity. That will not give you what is called as the instantaneous velocity. Okay, now the one thing you need to know about velocity is that since it's the derivative of x with respect to time, on a position versus time graph, it represents the slope at any one point. Okay, so since it is the derivative of position with respect to time, on a position versus time graph, it represents the slope at any one time. Okay. And what else does this mean? If v equals dx by dt, then dx equals v dt. Integrating, we get delta x is equal to the integral of v dt. So on a velocity versus time graph, the displacement between any two time points can be found by finding the area under the graph. Okay? So now that we've understand how to find displacement, velocity, and position, let's talk about the units. In the SI unit system, which is most used in physics, position and displacement are use the unit of meters. Note that the meter is a base unit of the SI system, so it's not formed by any other units. And the velocity is defined as the meter per second, okay? Because meters per second, dimensional analysis. Okay, now let's move on to some acceleration. Okay, the average acceleration is delta v over delta t. If we take the limit as the delta t goes to 0, we get the instantaneous acceleration, which I will just write as a, to be equal to dv over dt. And since v equals dx by dt, this can also be written as d squared x over dt squared. Same thing as v dot or x double dot. And since acceleration is the derivative of velocity with respect to time, the slope of the velocity versus time graph is the acceleration, and the area under the acceleration versus time graph is the change in velocity. A lot of people get this wrong, okay? The change in velocity is the area under the acceleration versus time graph. So, for example, let's say we have the velocity versus time graph. The slope at any one point, that is acceleration. That is acceleration. That is acceleration. On an acceleration versus time graph, however, the area under that graph refers to the change in velocity at any one moment in time. You can just do that by separating variables and integrating. Okay? Now that we understand the definitions, we will now use these to derive some certain things called the kinematics equations, which are very beneficial to us since this is kinematics. Thank you very much for watching this video, and please subscribe and like and post a comment to support the channel, and have a good day.